especially for the mentees. So the University of Calgary Solar Car team will be coming up with a presentation for around 15 to 20 minutes. So all of you are encouraged to be in that presentation, and the mentees who will be staying there will be earning 25 Ignite points. So yeah, so I hope you guys don't want to miss out that opportunity. Um, that saying, let's move on to our content for today. So let me just go present you. All right. So for today session, we'll be talking about an application of software engineering, one we've already said previously in one of the previous sessions. The next part would be how a way to actually check for mouse clicks. We've actually dealt with that in one of the previous sessions, probably in session 5. And we're going to learn another function that's related to the mouse clicks. And the third part would be the most important one, that would be functions. Okay. So deep bar, which is basically the combination of chemistry and machine learning. So a common thing that we all understand is that whenever we're talking about software engineering or computational stuffs, we often think that it's kind of related to stuff like robots or maybe computers or anything that's similar to of that sort. However, over here, you can see this is basically the image of a drug molecule, okay? And it's actually targeting the protein over here. So what this basically does is these drugs are actually sticking to their target proteins, right? So in some ways, the stickiness can be thought of as a good indicator of effectiveness, okay? So in order to calculate this stickiness, if you want to do it computationally, it's really expensive. So a group of MIT scientists have figured out a way to actually use the machine learning models, and they are getting quite the same results within a very fraction of time, and it has been really efficient and helpful as well. So you guys can actually learn more about it by searching out this keyword that's called deep bar in Google and learn more about it as well. Okay. Moving on, let's go for a quick review about the for in range part that we've used in the previous session with for loop. So range is basically a list of numbers from 0 to 1 less than the number that you give in. So over here, if you type range of 5, that mainly means that it's going to be from 0 to 4 because indexing always starts from 0 and it does not include 5. There are two examples. One of them over here with a simple one, for loop for I in range 5, so print 5 times, which is basically this statement, repeat 5 times, will be printed out. And then we have another example where we're working with list. So we have log, that's basically, it has 4 elements instead of this list, and we have size, it also has 4 elements. So we are looping over 4 times, and we are using the values over here to be the parameters of the circle function that we'll learn from session 1, okay? So each and every single time, so this loop will be continuing for 4 times. Initially 40 would be the value over here, and then 100, and then 12. So this is how it's going to be like going on every single time. So the new topic we are going to be actually looking over here is a part of the mouse input that we've learned. So it's called mouse underscore down. Okay. So what if we wanted to actually do something only once when we click on the mouse? Okay. So for that purpose, for that, we can use the mouse underscore down function. So the syntax is pretty simple. We basically type in def mouse underscore down, and we can do anything that we want to do. We can maybe create a circle or maybe create a rectangle, anything that we want to do. So let's go for a quick example. So we add the mouse underscore down to our code the same way we actually do for setup and drop. Okay. So the def setup function is over here, and the size give a size, background, and a fill style. Okay. Now, what we usually do is for mouse underscore down, rather than typing it inside of the draw function, what we want to do is like in a mouse click, there would be a circle that will be formed with mouse underscore x and mouse underscore y. So whatever the position would be, the x coordinate and the y coordinate with a diameter of 50. Okay. So I actually did that example in Jupyter Notebook. So as you can see, let me just run it again. So when we click, we see that a square circle has been formed, and then we click again, it's been formed again. So yeah, this is how it works. Pretty simple one. The next thing that we have for today is basically functions, which is by far one of the most important and fundamental concepts. So let's get to know about what is actually a function. Okay, so functions are blocks of code with a name that we can call to perform a single task for us. Okay, so this lets us run a bunch of code from a single line. So suppose we wrote 5 lines over here in this place, and we are calling them through a function. So it's really very efficient, and we'll actually get to know why. So what's the point? By packaging blocks of code into functions, we can reuse this code whenever we want to. And using function also makes our code much shorter. We don't need to rewrite that same code again and again. We can just call a function. Okay. So think about, let's take a brief analogy about by taking this example. So suppose a car has a lot of complex pieces. Each one is like a function. The gas pedal, which is basically for moving forward, the steering wheel for changing the directions, the brake pedal for slowing down. So these three and many more components simplify the complex mechanisms of the car, right? So, for example, when you press the gas, so the input will be like your foot presses the pedal, right, over here. And the process that's going on inside of this in this part is that the gas flow increases into the engine burns harder, the wheel spins with more force, and the output would be that the car moves faster. So we can see that a lot of stuffs are happening behind the scenes. We're just like pressing the pedal, and all these stuffs are happening behind the scene. We are not able to see it, and but we can basically realize that the car moves faster when we are actually pressing it. Okay. But the drivers just push the gas and go fast. So function will allow us to actually simplify our code in a similar way. Okay. So let's talk about predefined functions. So far, we have been actually using functions for a while. And one of the ones that we have been using are print, circle, fill underscore style, background, and rectangle also as an alternative of circle. So yeah, they just do a single action for us. Okay, they only do a single action. We have to keep that in mind. So return values. So there are some other functions that actually give us back a return value when they are called. The list underscore length. Okay, so we use the length function. We've learned about the length function, and what this basically calculates is the length or the total number of elements inside of the list, right? So it returns the length of the my underscore list and stores it inside the list underscore length. So it takes it gets the length and stores it inside the list underscore length variable. And there is also another function that it's called randint. So this actually returns a random number between 0 and 10 and stores it inside of the random underscore num function. All right. We also can actually make our own functions, and we can create our own functions that can do anything that we want them to do when they are called. The body and the syntax is very simple. We basically type in the function name and we type in the commands that we want that function to execute. Okay, now let's take a look at this example. What if we wanted to draw a town with a lot of houses? Let's see what would look like, what would that actually look like without using function. So we would basically start off by giving a size and a background. And for each particular house, we're going to do this. We are actually repeating this 1, 2, 3, 4, 5, 6 lines of code. Over here, we've written it 6 times. We've written it like 6 times, probably for 5 times actually, for 5 different houses in different positions. Okay, so in this order, we can say that it's actually quite inefficient because we have to repeat the same code again and again. Okay, so here comes actually the benefits of function. So using function, our code is now much shorter. Instead of repeating the code, we can use a function to draw each house. So over here, you can see we have actually inside of the setup function, we've actually called this draw house function. So before actually calling the draw house function, let's create the draw house function over here. What we're doing is we're taking two parameters, x and y, basically for the x coordinate and the y coordinate. Okay, and then we are for each of them we are giving a fill style of white. A rectangle will be formed, a triangle will be formed, and all the other properties that are over here. Now we are calling this function draw underscore house instead of the setup function. So what is happening is there every single time we are giving in 40, 40, 220, 40. These are basically the positions, right? For X and Y. So for the coordinates that are actually happening. So if you look back, you can see like it had around it had a lot it had a huge amount of code. I mean, it's because we repeated same time, but now it's quite short. So we made our uh, code a lot more efficient and also readable for the users. So before moving into the quick question, do you guys have any questions?
Excuse me, can I see the code again?
Oh, yes, sure.
Computer crashed. Okay, thank you.
All right, so we will be moving on to our first quick question. So which of the following is false? So take a look at this and put the answer in the poll that's right in front of your screen. Okay, so I hope y'all got the chance to actually put in your answers. So let's take a look at which of these over here is wrong. So yeah, functions should be used, functions can be utilized as reusable chunks of code. Yeah, we can actually use that. That's why we're using functions. Functions should be used to perform one specific action. Yes, the predefined functions are basically used for performing one specific action. Functions can only be called inside of the draw function. Well, this is incorrect because in the previous slide, we've seen that we called the function inside of the setup, so there is no limitation that it can only be called inside of the draw function. Okay, so one point that I wanted to spot out was that in the predefined functions that we've seen previously, which are print, circle, rect. So over here, the functions are actually performing one specific action. But take a look at the function that's over here, draw underscore house. So it's not only performing one specific thing, it's like doing, so this is a user defined function. So it is doing this tasks that are actually defined by the user. So it's creating a rectangle, a triangle, doing for black fill style and also white fill style. So a lot of things. Okay. So yeah, make sure that you guys don't actually get confused in those two parts. So let's make our own functions. Here's the anatomy of a function. So we type in def as usual, and then we type in the function name, and we have to include the parameters over here as well. The function body and a return value. So stuff that are actually required for when you're actually creating the function. So the name that's required, body is also required. Parameters optional, return value is optional. You may want to return a value or you may not. In the parameter works in the same case as well. Okay. The next, the function names. All functions have a name. This is what we used to call our function. So over here we are actually replacing them with greeting. So here we create a function with the greeting. This function currently has no body, parameters, or return value because we did not actually specify anything over here yet. Next, we are going with the function body. So function body is basically the chunk of code that you will be writing inside of the function. So suppose in the greeting function, we are writing print hello. And now this is the code that will run when we actually call the greeting function. Okay. A simple example, we have our first main function. This function just does something, no parameters, no return values, no complexities, nothing. The name is just greeting. The body is one line, print hello. So yeah, that's it. Next, we are adding our function in our code. So it is important when we create our functions in our program. So we have to set up as usual with the background this. And what we do is like we create the function greeting with print hello everyone. Okay, so nothing to starting. So yeah, now what we have to actually do is calling our function. Okay, let's actually code it down over here. Put a bullet percent ignite setup. Okay. Size 500 500. Draw function. We want it to be 175. 5. Use the string over here. Next, create our own greeting function. Okay. Now what we will be doing is okay. All right. Is this slide be visible to you guys, or do I have to zoom it more? Right, so you'll be able to see this. Okay, sure. That's a lot cleared up. Okay. So actually now what we have to do is adding our function in our code. So we have written down the code. Now we will be calling this greeting function. It's important where we actually create our functions in our program. Okay. So yeah, so we have to create our functions outside of the setup and drop. Okay, we have to make sure that we are not actually creating a function inside of both this functions over here, because we will be messing it up if we do that. Next. So what we will be doing is we have to call this greeting function that we have created over here. So we will be calling it inside of setup. So suppose call it over here. So let's see. Oh, okay. Percent. Oops. Okay, so as you can see, we called the function, this greeting function, instead of the setup. So it gave us the text, hello everyone, and we actually got the background that we're looking for over here. Okay, so yeah. So this is the first exercise for you guys today, and so it's about create a function called random underscore circle that gets called when the mouse is pressed. The function should draw a circle at the mouse position with a random diameter and a random color. So we've learned about all this stuff in the previous slides. So we have to use the mouse underscore down function, and we have to use the randint function. So these are basically the so randint function is basically a predefined function. So yeah, it's quite similar to the example that I've showed you in the mouse underscore down function. Now you guys will be sent out to breakout rooms to actually work on it. And I think you guys are gonna have around 10 minutes to actually work on that. All right, so I hope you guys try to solve it during the breakout rooms, but if not, I'm just gonna go over it real quick. So as usual, we start with by typing in percent in guide, and now let's create our setup function. We're gonna give it a size of 500, 500, and a background that's like a light color background. Let's go to 40, 40, and 40. Okay. Okay, let's go to 40. Yeah. So basically, as you can see, a circle is being formed, right? So it has different colors. It doesn't have the same color. So for that purpose, we will be basically using the random function. So let's actually define a function that's called draw. Let's call random circle. Okay. Now what we will be doing is we will be generating like different values of red from out of the 256 hex value, right? And we're gonna do that for green as well. Okay. And same thing for blue. All right. Now, for the diameter over here, we have to give so we have to be like having within a range of 25 to 75. So for that, for the diameter, what we're gonna do is you type in like it will, as you can see, the circles over here, the circles over here have different diameters. For that, we are also going to use that random function. So we're going to have the t, and at most we can have till 75. So 25 is the most that we can go with, and we're going to give the fill underscore style to be r, comma g, comma b. Okay. Now, we are also drawing the circle, right? So for that, where are we drawing the circle? Anywhere on the screen where we want to. So for that purpose, we're going to mouse underscore x, mouse underscore y, and the last one will be d. All right. So now, since we're using the circle function, obviously we need to create the draw function over here as well. And one thing that we need to check if the mouse is pressed or not. Okay. So for that reason, we have to type in if mouse underscore pressed. If that condition is correct, then we can call this random circle function that we have created over here. Okay. So that should work. Let's actually try run again. Okay, so fill underscore style. Oh, that was a typo, I think. Yep, it should be small. So as you can see, we are actually having different types of circles in any position of the screen we want to. So what's going on over here is that we are having different diameters, different colors, and everything that's required for this first exercise. Okay, so moving on, let's actually now deal with parameters. So for in the first exercise, we didn't have to deal with parameters. Now, parameters are optional variables that are used as inputs by the function. The stuff that we write inside of the parentheses. The function body treats them like normal variables. Okay. However, you don't set the value gets paused and when the function is called. Okay. So let's take an example. This is a function that adds two numbers together. It takes the parameters a and b, and it brings the sum of the two inputs. The parameter a and b has been taken as input, and for the sum, what it does is so the sum variable, the sum variable we're storing here, the a plus b value, okay, and we're printing it out now. So suppose the setup calls add with the inputs 3, 5. And inside add, the function body takes a is 3, b is 5. So let's look at the diagram. It's going to be a lot more clear. So we have our setup function over here, as usual, with the size. And the function that we created is add, okay? It takes in two parameter values, a and b, all right? So now, what it does is it calculates their sum, and it's stored in the variable that's called sum, and we're printing the sum. So we are calling this function inside of the setup function, and we are actually putting the values of a, we are passing in the values which are 3 and 5. So the first variable is a. So a over here right now is 3, and the second variable is b. So 5 over here is now referring to be the current value of b. So a is 3, b is 5. So in that case, we will get the sum to be 8. Okay, so this is how when we are actually calling a function with parameters, this is how the analogy works. So let's go for a quick question 2. So you have to fill in the blanks. It's very simple. So the poll will be right up on your screen. And make sure you guys put in your answers real quick. I'll be closing out the poll in the next 30 seconds. So make sure you guys put in your answers real quick. I hope it's done. All right. So let's look at the answer over here. So this is real simple. The example that I was showing previously. So over here, blank underscore one will basically be divide underscore by underscore three. This function will be here. And 10 point, and over here you can see it's numbered by three, so it will be numbered. So option two is the correct one over here. So yeah, so 10.32 is basically the value that is passed in this function, and we will be getting out the float value afterwards when we print out the result. Okay, so now let's look at the return value. So some functions can have a return value. This is what the function gives back to us. So the structure is we just type return after the end of the function body. So the values can be anything, such as a number or even a string. Um, a quick example over here is it's a function that has a return value. It just returns an integer and it does not take in any parameters. Okay. Uh, Suppose over here you have x that has the function 2 underscore plus underscore 2, and we're printing x plus 1. So 2 underscore plus underscore 2 is basically calculating the answer over here, which is 2 plus 2. Okay, so we are returning this answer. Now this is actually getting passed in this variable that's called x. So now this is being calculated over here with x plus 1. So what we are getting here is we're returning the answer. So we are having here 4, and this, since this function is getting called over here, so it's like 4 plus 1, and it gives us 5. Okay, let's look at another example. So we have area, calculate underscore square underscore area 2, and we are printing out two statements. A square with side length 2 has area this, and we are printing out the area. So calculate underscore square underscore area. What it basically does is it takes in the parameter side underscore length. So over here, what it does is returns the product of its square. Okay, so over here we're passing in the value 2, so it's going to be like 2 into 2, 4, and then we're actually getting the square, the area of the square. So this is exercise 2. Tag it all together. So create a function named average that returns the average of inputs x and y. When the mouse is pressed, we call the average and pass in mouse underscore x and mouse underscore y as the parameters. So draw a stroke circle at position of the mouse with the return value average as the diameter. So you guys will be set up to breakout rooms right now, and I'll be giving you guys around 12 minutes to work on this exercise. All right, let's try to go to the second exercise which we have. Got it. Right, so basically over here we're just gonna be like creating the circles as you can see, and yes, to have a picture as usual, we go with the setup, size. Next, we actually have to create a function that calculates the average. We pass in the values AB, parameters AB. For that, we return A plus B slash 2. Right. Next, what we will be doing is, since we're going to be creating circles, so let's actually call the draw function. So over here, I think we have to use, yeah, we have to use mouse underscore pressed. If mouse underscore pressed. Right, so the function is just a condition. We will be calling that average function, but we will be having a different diameter of circles. So for that, let's call the average function. Average was x, so y, comma d, x. Circle function. D. Right. I think that, oh, okay. Should be D over here. So these two values will be paused as A and B. And we're missing anything. Oh, we're missing the background. So the background would be 225, and 239. Right. I think we got it. Right, checking. Okay, so yeah, we can just click, and then if you want to drag it, it's working. So that was basically it for the second exercise that we have. So on the next slide, it's basically about the keywords that we've learned, global and local. So which functions are mainly global. So just like in draw setup, if you want to use other variables inside of own functions, we can use the global. So the global variable over here is held, that equals to 5. So over here, we are actually taking this value of 5, okay, in the take underscore damage function. So that's why, since it's a global one, we're declaring it to be global underscore global health, and we're having health make it equals to 1. And we're just calculating whatever we need to do, and then we're calling it this function, the setup function as well. Right, so it's not much of a big deal, just to make sure that you guys are familiar with the concept that we can also use global and local variables if you want to in the functions. So that's it pretty much for the slides. So we have the blockbuster exercises over here. So and also the Pythonic lovers, and these are just for fun. So I'd like to actually give out some notes for this. So this is basically for the first exercise. And for the blockbusters, and this is for the second. So once again, you guys will be sent to breakout rooms to actually work on this along with your mentors. So You guys can have around, you guys can work till around 7:25, and then come back again for the after the record closes. And also just a quick reminder that after the Schulich Ignite session gets over, there will be a presentation by the solar car team from University of Calgary. Uh, yeah, it will be around 15 to 20 minutes, and the mentees will be staying, and being there will earn 25 Ignite points. All right, so you guys will be sent out to breakout rooms right now again to work on these exercises. All right, mentees. So I hope you guys tried working on those projects along with your mentors. So one last poll for this session today, and it will be coming up into your screen very shortly. Make sure you guys put in your answers real quick. We'll be closing the poll in the next 30 seconds, so make sure you guys put in your answers. All right, so that's basically it for today's session in Schulich Ignite. I'd like to hand it over to Dimitar for discussing about the University of Calgary Solar Core team. So Dimitar, you can take over from now on.
Yeah, thank you. So we do have two representatives from the University of Calgary Solar Car team. They'll be here for just a quick 20-minute presentation talking about their team and what they do, specifically how software plays a role in it. So yeah, we hope you guys will stay for the presentation and get to learn a little bit about how software is applied in a bunch of different ways. And if you do stay for the session, we will be awarding 25 Ignite points to the mentees that do decide to stay. So yeah, that's everything that we have from our side. Now I'll pass it over to Jesse and Hisham to take over.
Thank you, and thank you for having us here today. Let me just quickly share my screen. Are you able to see my screen?
Yes.
Yeah. Okay, great. So hello everyone. We're here. We're very excited to be here with you today. Just a quick introduction. My name is Jesse. I am currently the software manager, and I'm currently in my 4th year of computer science and finance.
All right. So my name is Hisham. I'm in my 3rd year of software engineering at the University of Calgary. On the team, I'm part of a sub-team called the Visual Communications team, and I'm very happy to be here with all of you today.
We are both members of the University of Calgary Solar Car team, and this team is a multidisciplinary undergraduate team of undergraduate students with the goal of promoting sustainability by building solar-powered vehicles. Today we'll be sharing a little bit about our project and how we utilize coding in solar car. Feel free to unmute your mic or ask any question in the chat as we go along. To start off, I will tell you a bit about our team. We were founded in 2004 by a group of undergraduate engineering students. Over the years, our team have grown to over 80 members, which are undergraduate students. Our team consists of multiple sub-teams who are in charge of different components of the car, which we will be talking more about later on. We all work to design, build, and raise a solar-powered electrical vehicle. So what exactly is a solar car? And essentially, it is exactly what it sounds like. It's an electrical vehicle, which uses solar power to run. In its simplest form, we get solar energy from the sun, which we use to charge a battery. The battery stores this energy, which we can then use to power the motors that we use to drive.
All right, so building a functioning solar car is a bit like a difficult puzzle, and as a result, they often look way different than a traditional car. So our main challenge is being limited by the energy input to energy output. Solar energy doesn't always generate a ton of power, so we need to design our car to be as efficient as possible to overcome this challenge. Things like aerodynamics, motor efficiency, energy storage, weight, and friction with the ground are all major factors we consider to make our vehicle as efficient as we can. So how is coding used every day then? If this was the 1970s, we might have had a simple answer for this question. But as you probably know, nearly everything you interact with that's been made in the last 10 years has probably been running off some sort of code. Everything from obvious softwares like your operating system to things not so obvious like cars. Before Teslas and electric cars became prevalent in mainstream media, when you thought of a regular car, most people didn't go straight to thinking, oh, I wonder what the software component is like, or is, wow, software must be a critical part of the functionality. Most people think about what kind of specs it has, whether it's like all-wheel drive or front-wheel drive, its fuel efficiency, its comfort, and stuff like that. But without code, most cars wouldn't even be able to start. So today we're going to show you what code goes on under the hood, so to speak, in the solar car. But before we do, we wanted to ask you guys, what are some of the ways that you think programming is used to make a solar powered car? And you guys can feel free to like unmute or just type out in the chat. We'd love to hear from you guys. Yeah, for sure. Yeah, like starting an engine is a pretty big part of that. Like we have, like once you, I guess, put the key in ignition, so to speak, we have different startup scripts to like tell the different parts of the car that they need to start going. Yeah, gathering data from the sensors is also a really good one. So we're gonna actually be talking about that a lot in the coming slides. For the GPS, not in our car, but not yet though. We want to look into that and have GPS. That would be something really cool to be able to implement to make it feel more like a regular car that you can just get in and drive every day. Yeah, charging a car is a really good one. Determining how much energy. Yes, so we have different techniques for doing that. And then yeah, again, solar to tell when the battery's fully charged. Exactly. Yeah, that's a really good one as well. So yeah, these are really good answers, guys. Great job.
All right, let's moving on. Really good answers, by the way. So on our software team, we have the sub-team, Embedded Telemetry and Visual Communications, or VisCom for short. All three teams are critical to the functionality of the car. The embedded team programs our electrical boards, Telemetry does data analysis and presentation, and finally, VisCom controls our data communication network and also works on our in-car visual systems.
So how does code move our car? So first, we're going to take a look at one of the most important functions of code actually being actually making the car move. So being able to drive is one of the prerequisites for being a car, of course. Gas vehicles have a mechanical system that explodes fuel to create the energy needed to turn the wheels. But in an electric vehicle, you can't quite use the same mechanism. So on to the next question I wanted to ask of you guys. How do you think different electrical components like the motors, for example, in the car will communicate with each other? And again, feel free to unmute or type in the chat however you're comfortable. Yeah, exactly. Sending signals is exactly the answer. So they communicate by sending messages to each other. So we have this diagram here of something called the CAN message. We'll be discussing that more in detail later, but essentially electrical boards can send this type of message to each other. And yeah, we'll be talking about that more coming up, so don't worry. So for the car to actually be able to move, if you press the gas or press the brakes, there must be some kind of communication between the gas and the motors, right? So in this picture, we were trying to illustrate that, like, for example, you have your dash cluster, it's communicating with the central system, same with like your locks and your windows, as well as like your key fob. Those all communicate through a CAN bus in your car. So on our team, the embedded subteam handles exactly these kinds of tasks. So they work with the communication network between the boards. Say you have a serious issue with the battery, you want to be able to communicate and interpret that issue as fast as possible so you can take appropriate action to prevent issues from happening. So yeah, this is an example of what could happen if you too late to interpret like warning signs or just issues in general. So in 2019, there was a Dutch solar car team that unfortunately had their car catch fire with just 250 kilometers left from from the finish line. So yeah, as you may remember earlier, I was talking about a communications protocol called the CAN message, and that just stands for Controller Area Network. CAN is basically a set of rules for transmitting and receiving messages. The electrical boards can send CAN messages to each other and are transmitted on something called the CAN bus. So to put it in simpler terms, you can think of a bus as a set of wires that you can use to transport data. So each CAN message has a specific structure that must be followed so that the receiving board is able to understand and interpret the message. So in the embedded subteam, the job is to program the boards to decipher the messages and take appropriate action. So in our 5th generation car, that's the one that you've been seeing all those pictures of, we have 7 boards with 4 of those being designed in-house by members of the team. And then the other 3 that we've purchased from proprietary manufacturers shown in the gray boxes. So each board controls different things, all of which communicate through the CAN bus, like I said. And as you may guess already, the embedded team works with many lower level operations. So often bitwise operations. So in this team, the code is mainly in the C language.
So in addition to actually making the car move, code also helps us in strategizing the car's performance during a race. We do this by collecting data about that car while it's on the road and using this information to help us make real-time decisions about how to most efficiently drive the car. So, you guys wanted to figure out what that binary says? Good luck. But anyways, what kind of information do you think we need to keep track of during a solar car race? Speed or battery, yeah. Heat, yeah, heat is a very important one. You don't want the battery overheating. Hmm. Yeah. Overheating is definitely a very dangerous situation that we definitely need to keep track of. Yes. Anyone have anything else? Direction, energy, yeah. I guess like charge, battery charge instead of. Yeah, where the car turns. Mhm. So yeah, these are great answers, and I can show you exactly what we track in our telemetry website. So this is our telemetry website, and this shows all the information that we keep track of from the car. So we had someone said temperature, cell voltage, cat current, and some controls. You can see if the headlights are turned off or whether they're turning on the signals or not. Um, Motor systems, and then all these faults. So these are like warning signals and something's wrong. You gotta know that. And yeah, there's also some race data, plus some graphs and all that. Yeah, actually say. So what you just saw was the telemetry website that is used by our race strategy team during the race. This website, as you can tell, is incredibly valuable during the race because it allows us to see the state of the car at that moment. We capture an enormous amount of information to where you can pretty much literally visualize what is happening in the car at that moment, which is very critical during the race because the team must know what's happening in precise detail in order to plan ahead. With all this data that we collect, we can also perform many data analysis and devise better strategies to improve our timings. So as you can see, there's a lot of information that the car generates, and we want to make sure that we capture the useful ones as much as possible. So the telemetry team works with the Viscom team to make sure that the data gets sent up to the telemetry server in a timely manner. The telemetry team then fetches the data and presents it on a telemetry website. You can see the little diagram. Got the solar car that has a lot of data, just magically makes its way on the internet, and then magically makes its way on a telemetry server. Sort of how the network looks like. The front end of this telemetry website is made using Angular, which is a web framework, and the back end is done using Node.js, which is also a framework. The telemetry team is also responsible for our public-facing website. So if you search us on Google, you'll probably end up seeing this page. Our website was entirely redesigned and developed this past year. Having a proper website helps us track and inform sponsors for our team, and in general makes it a better way to showcase the work we do. Without the public outreach or sponsors, we would never be able to put this car on the track. The public-facing website is also made using Angular, but the backend is made using Google Firebase.
All right, so how can code enhance the user experience? So the code allows us to drive the car and improve its performance, like we said, but it can also be used to enhance the user experience. So our solar car is kitted out with a touchscreen, a dashboard, and sound system, which makes it feel more like a real car and makes it feel more like a real car rather than a race car and much more enjoyable to use. So another question for you guys. What are some of the useful and fun features you think we could use our dashboard for? More cars. I'm not sure what you mean by that. Energy? Yeah, we definitely do display the energy on our dashboard. Yeah, speed, of course. Yeah, like an animation of the car. Yeah, so Like some modern cars will have animations of their car. Like for example, they'll like show the tires spinning or like an entire visualization of the car. That's something that's really, really cool to have. And so we were trying to work on something similar. So it's definitely something that's really fun to have. And then testing real life applications. Yeah, so testing is a big one that we would use our screen for, and fuel efficiency, stuff like lights and audio, of course. And then I guess we were kind of joking around, some of us on the team. We were saying like maybe we could have like a fireplace mode, you know? It's just like just play a video or something of like fire burning on logs. That would be pretty nice to have. But yeah, these are all very good answers. Thank you so much for participating, guys. So yeah, like you guys said, so without a dashboard, how would we know how fast we were going? So the visual communications team handles all sort of visual components inside the car. So this means our dashboard, our media player, and the center screen. So you can think of our dashboards like the ones in Teslas, because our dashboards are all digital. Like we don't have any physical buttons in the car. So what is unique about our dashboard is that it's tailored for the competition and for our drivers. So unlike a regular electric car, we don't just have charge status, but we also show things like charge efficiency, voltages, errors on the dashboard, so the drivers are always aware in the situation in the car. So we also have a media player and the center entertainment touchscreen to make it feel more like a commercial car. We're also trying to integrate Android Auto and both Apple CarPlay, so people can have a more customized experience inside the car. You know, you can like bring your own music and stuff like that. I think that would be something that's really cool. So all of these displays are hooked up together in a mini computer known as the Raspberry Pi. So that's the picture in the top right there. And they're pretty useful. They let us run all sorts of things. So yeah, the Raspberry Pi is the center point for the communication point uh, between the communication points for the car data and the telemetry site. So we use something called Hermes, which we've illustrated with the actual picture of the Greek god there. That takes the messages from our central communication system, which is that red circuit board, and the resulting information from the CAN network. So what Hermes does is that it broadcasts that in a format called the JSON format. So essentially what that is, it's a more readable format that we can use to interpret in our dashboards as well as our telemetry servers. So in these kinds of applications, we'd be working more in C++.
As you can see, all of the subteams are quite intertwined. Not one subteam is completely isolated from the other. Each one depends on one another, and together we make the car move. Without software, the car wouldn't work. We wouldn't be able to know what's happening, and we also would not be the team as we are now. Although what we do may not be completely obvious, software development is still incredibly important. In general, with how modern our world is, there is code in every nook and corner that is supporting critical systems. So learn to code. You guys are doing great. Hopefully you learned a little about programming used in the automobile industry and in engineering broadly. We are super happy that we were able to share our project with you, and we would like to thank Sheila Goodnight for giving us this time. Before we wrap up, we wanted to mention that our team is always looking for new and talented students with a passion for sustainability to join us. Being part of the Solar Car team is a fantastic opportunity to expand your extracurricular skill set and build some great experience for your resume. I know that personally, I have learned a lot about programming and teamwork as a team in a way that you don't get exposed to in like, normal skill classes. So if you decide to go to University of Calgary and you like cars, you want to put your coding skills to the test, we are the perfect team for you. We host our member recruitment sessions at the beginning of each university year, and we'd love to meet you guys there. That sort of wraps up our presentations. Before, do you guys have any questions? Feel free to type in the chat or unmute yourself. Do we plan on mass producing our car? No, not right now. Simply because one car takes us about 4 years to make, so it'll be kind of really hard to make a whole bunch of it with the people that we have now. So yeah. Yes. Unfortunately, you do have to be a University of Calgary student to be able to join this team. There are actually a lot of solar car teams across universities in Canada and the United States. Like I know Waterloo also has a solar car team. So does UBC, I think. So there's probably something like that in our universities around. Can you join the solar car team? You can apply. What is the project that software team is working on right now? Currently we're building our new 6th generation car called Helios. So there's a lot of stuff to be done for that. Like the dashboard needs to be made, telemetry website also needs to be updated, and then new boards also needs to be programmed. So there's a lot of planning and designing for that car right now. So that's mainly what we're focusing on currently. Mhm. What do people in this program usually major or study in general? Do you mean like in software or in solar car? Both. In software, mostly software engineers, and in solar car in general, engineers. If you're in mechanical engineering, most people are in mechanical. Or sorry, if you're on the mechanical team, most people are in mechanical engineering. If you're on the electrical team, most people are in electrical engineering. That's in the business, then you get a little bit more variety. But yeah, engineering.
But that's not to say that we only take engineers either. We would love to have everyone that we can, as long as they're very passionate and committed to us. So honestly, if you feel like, maybe you're not going to like an engineering discipline, but you're ready to like get down and dirty, we're always happy to have people like that on our team.
Yeah, exactly. Yeah. I guess like I'm sort of the odd one out. I'm in computer science, but I'm also in finance, not an engineer. Another question, how important is calculus used in the software team? We don't do any of that.
Yeah,
Uh,
no.
yeah, whatever, like, you guys are in high school, so math 30, 31, probably. You should know some basic math, like you're adding, multiplication, subtracting, those are used. But when I do like differential calculus or like differential equations or whatever that, we don't really do that. Any last questions? Not then. If you have any more questions that we can get to you today, you can always DM us on Instagram or email us or I don't know, get on any of these social media, message us, and respond to your questions. That said, feel free to follow us on Instagram, Facebook, LinkedIn. And yeah, thank you again, Sheila, good night, and everyone for listening and having us today. And yeah, I'll
Thank you
pass
for your
it
time,
back.
everyone. It's an honor to be here today.
Thank you.
Thank you, guys. Oh, the presentation was great. So for our mentees that did stay, we'll just have this quick poll that we would like you to fill out. You can select either of the choices, but it just helps us keep track of who stayed for the presentation. And then after that, that wraps up today's session. We'll see everyone next week. Thanks, everyone.
Bye.
And so for the mentors, we won't have a debrief session today as well, just because we did have this presentation.
Catch you next week then.
Have a good night.